I'm sure you'll agree that although that was interesting footage, the quality was shite. The camera vibration was no good at all. This is the camera I use for 95% of my video. This is the camera that video was taken on. Little Panasonic digital camera. I've got 2 or 3 of these. Whenever they come up on eBay, I buy the same camera. That's a lens I put on and a slightly bigger battery, but they are an excellent camera. I've been doing some research on different camera mounts, and what seems to work quite well is what they call a wire rope camera mount. I've seen a few different variants. I'm going to make a one because they're expensive, but I'm going to make a one that I can adjust until I get the weight of the rope right. Basically what they use loops of wire rope like that, and the wire rope loop is a medium to take away the vibration. So I've got 2 bits of aluminium here. I'm going to drill holes in, and I'm going to lace the aluminium round so those 2 are held apart by coils of this stainless steel wire. One end goes onto the camera mount, one end goes onto the camera, so the camera is then able to absorb the small movements. The movements, if it's not big jumpy up and down ones, it's just basic vibration that's coming from the steam wagon. So that's the idea. I'm going to drill some holes in here, make them probably 100mm long, drill holes on 20mm centres, and then we're going to lace the wire rope through with a couple of grub screws in each one, and I can change how many coils of rope I have and how long each coil is until I get something that will support the weight of the camera and give us the damping effect or the anti-vibration effect that I want. I did try making one of these some time ago using rubber, it just didn't work. But the wire rope one certainly appears to work. I think they're using, like the film industry using the same sort of mount, an electronic gimbal, but they still have one of these on to absorb the high frequency vibration, I would call it. So the first thing I'm going to do, make these the same length, mark them out, drill some holes through, and holes for grub screws, and then we'll go from there. Just going to square up one end of each block, and I can measure them, get them both the same length. Use these Banggood cut as I reviewed the other week. I did say I would use the gear I've been reviewing just to get a bit of feedback on them to see what they're like. I keep waiting for the mill to make a nasty squeaking noise, but when now it hasn't. You notice how it was jumping when it was cutting there, that's because it was plain milling. Going with the direction of rotation, we need to go into the direction of rotation. With a lightweight machine like this, you don't want to be doing plain milling. These really do cut aluminium and put a nice finish on as well. A little bit of WD-40. Last cut. That's nice. Right, so now we've got 2 the same length, they're both 116mm long. Right, I need to put this in the drill chuck and then drill a series of holes in there I'm going to use them for parallels. All it is, it's banding, heavy duty banding, the sort of stuff they use for wrapping big packages up with. Nice and flexible, disposable, and it's surprisingly accurately the same width. A little nip on the vase, and then a little bit more nip on the vase. Right, so that's down on them parallels. It doesn't matter if you move and you clip them with a drill. That's sort of consumables. You can buy what they call a wavy parallel. Idiot. A wavy parallel, which is one of these bent like a crinkly shape. They're very handy as well. You can make your own. Makes good packing as well. It's ideal stuff. Right, first thing to do is find the centre with a piece of bar, and then we'll work our whole patterns out from. You can use whatever method you want to find the centre. This is pretty good for the video because you can see what's going on. I've shown these before. Then you bring your part across until it touches the bearing. The bearing will stop turning. Then we'll slow it down. Right, so we'll zero the axis on the milling machine. Go to the other side. Do exactly the same thing. We'll just stop turning, floating there, that's it. Then all we'll do is half the axis, bring that to 0, and that's going to put that exactly on the centre. And we'll lock the table over that. There. Then we'll do the same thing on each end. That's it there. So that's the reading we've achieved on the x-axis. It doesn't matter what it is. Press that button there, then press half, and that brings a figure up which is absolutely half, or exactly half of what the other one was. Back to 0, and that puts us right in the centre of that piece of material. You can do the same thing using the hand wheels. But it's a lot easier using the DRO because you haven't got to worry about backlash. Right, the first hole is going to be 10mm from the centre. I mean, this is super accurate. You don't need to be as accurate as this, but we might as well use the gear for it's designed to be used for. Right, the wire rope's 4mm, so we're going to go with a 4mm hole first. That's the first one. I think we'll end up going up to probably 4.5. This is 4mm, yeah. Right, we'll put a 4.5 in and try that. Right, 4.5. Once again, this is bang good tooling. Right, that's pretty good. I've got some 6mm wire as well, so I might make the end tool loops out to 6mm, I don't know. So that's the first one at 15, at 10, and we're going to go at 10 each one, 10, 10 each one. So we're putting that 10 in. Right, now we've come back to the other side of the zero. We're going to use this little oil bottle. It's a bottle my friend Bob made. Actually did some video on making it, but I lost the video. Bob is going to be coming back and doing more video. Once I sort of get back on top of things, he's keen to do more videos on clock gauges and little workshop gadgets. These are absolutely brilliant. Right, the last two holes are going to be 5.5 because the other bit of wire I've got 5mm, which is a little bit stiffer, just to try. Right, so that's the last one at 50. This should give you some idea of what I'm trying to achieve. So the wire rope acts as a support. Camera goes on there. There'll be grub screws go through, so each one's locked. You can change the length of the loops to get more or less stiffness, really. The last time I played with a gear like this was we were making wire ropes for caving, gluing wire ropes and araldite wire ropes and aluminium rungs. But that's basically how it works. There's quite a lot of information on Google if you just are interested. Just type in wire rope anti-vibration mount, and they're used in all kinds of different things, not just cameras. Such a simple idea, but it certainly appears to work. So the next thing is to drill holes in, put grub screws in. I'll probably cut the wire to length instead of having it threaded through like that, I'm not sure. And I have put some bigger ones in the end for some 6mm wire. I don't know how much I'll actually need until I get it finished and try it, but I've certainly got enough in here to support the camera, a lot heavier than the one I use all the time. Once again, it's just time to say thanks for watching, thanks for subscribing, and as always, thanks for all the well wishes that are coming in. I'd like to give you one little bit of advice. If your parents are still alive, or you've got friends you haven't seen for a long time, go and see them. Don't say I'll go and see them next week. Go and see them now or tomorrow, because you just don't know what's on the corner. Anyway, thanks for watching.